We will also be responsible for factoring polynomials that look like this. Now, you might not see anything other than the fact that these do have a greatest common factor, but if we can just look for a common factor, not necessarily the greatest one, we may be able to turn this statement into a difference of two cubes. So if we just factor out a 2x, basically divide each of these two terms by 2x, look what happens. We get 125, which is a perfect cube. We'll get x to the third, which is a perfect cube. And if we take 128 divided by 2, we will get 64. And if we take x divided by x, we just get 1. So this entire expression really factors into 2x times the difference of two cubes. So we can continue to factor what's inside the parentheses. If we just look at this piece, and again, we have to save this 2x for later, we can look at 125 x to the third as really 5x to the third power minus, and then 64 is really 4 to the third power. So we can use our structure from before and realize that 5x is a and 4 is b. So this will factor into a and b in a binomial, a squared as the first term of a trinomial, b squared as the third term of a trinomial, and ab in the middle. Since this is a difference, we're going to look at SOAP. This would be the same sign, this would be the opposite sign, and this would always be positive. And now we can just substitute 5x in for a and 4 in for b in this expression. So we'd have 5x minus 4, parentheses, we'd be taking a squared, so we'd really be taking 5x and squaring it. We'd be adding it to a times b. Well, a is 5x and b is 4. So 5 times 4 would be 20. This would be plus 20x. And then we would add b squared. Well, b is 4, so we'd be taking 4 squared. So we'd have 5x minus 4, and 5 squared is 25, and x squared is x squared. So this would be 25x squared plus 20x plus 16, and we still have this factor of 2x that we could put either out front or in here. So this entire expression, 250x to the fourth minus 128x, would factor into 2x times 5x minus 4 times 25x squared plus 20x plus 16.